Measure it, and we're going to measure the load side without the relay. What does that accomplish? You want to know in electronics, you want to know how the component is working in the circuit. How am I going to measure it? When the terminals are inserted inside the fuse box, well, I'll show you how in the video. Where's a good point to start? I start right here. Right here. This is where I start. I put my probe here, my positive probe, my negative going to ground, my positive point right here, my probe goes here, and I measure 12 volts. What does that tell me? That accomplishes a lot to me. The fact that this measures 12 volts tells me this switch has moved from its rest position to this position, and that it's connected to 12 volts. What does that also tell me? That tells me this pulled this in by this coil. What does that mean? That means this has a 12 volts. That means this has a complete path to ground. If this would be a computer going to ground, it would tell me this was activated. I had a magnetic field and I pulled in the contacts to give me 12 volts. So in one shot, measuring at terminal 87 told me all this circuit is good, the control circuit is good. The load side of it is also good in one shot. I did not have to go measure 12 volts here, 12 volts here, 12 volts here, 0 volts here. No need to. If you leave the relay inside the circuit, the fact that I have 12 volts over here tells me this flipped. This is connected to 12 volts. The fact that I have 12 volts over here tells me this was energized because it pulled in this contact to give me the 12 volts in the first place. Now let's say I have 0 volts here. Let's say I have 0 volts over here. Now I'll say, okay, do I have 12 volts over here? I have 12 volts over here, but was this energized? Do I have 12 volts over here? Was this energized and was this going to ground? Then I work backwards. But the one-shot troubleshooting is, let me go to the point where I get all the information in one shot. And again, 12 volts over here tells me I'm connected to this, tells me this is working, tells me the computer is working if there would be a ground going to a computer. Not in this case, it's going to a physical ground, but let's say there would be a computer here, it would grounding it. This will tell me the computer grounds it. This will tell me the relay is good, 12 volts over here, 12 volts over here, and this flipped it. Everything on this side is good, everything on this side is good. That means the problem is after it. Now in reality, you're not going to measure 12 volts. You might measure maybe 11.5, 11.6 over here with the relay activated. But the fact that you measure 11.6 tells me that the relay is accomplishing something. The current is flowing. The 12 volts went down to 11.6, 11.7. That tells me that the relay is intact. That current is being drawn. That's why it's important to always leave the relay in the circuit. I cannot stress this more. Leave it in the circuit in the terminals. Do not take out the relay and say I measure 12 volts here. That to me is just nonsense of electronic troubleshooting. It makes no sense. It's like you have 3 resistors in series. I take out 1 resistor and I'm going to measure the voltages. Does that make sense? It makes no sense whatsoever. So anyway, I hope you understood this, and hopefully we'll do a physical demonstration on the relays and show you tomorrow. Remember these terminals, because on GM, these are the terminals. Please subscribe to my channel, Automotive Electronic Schematics by Joseph at Joe Electronic Schematics. And please go to the other videos. Like I said, I don't have too many tags or descriptions. So, like I said, I'm still working on it. Hopefully, you'll find it informative. Thanks for watching.